These slides cover organic acids and bases. Let's start with acids. Organic acids are called carboxylic acids. Carboxylic acids are a series that contain the carboxylate group. Now, the carboxylate group is written as COOH normally in formula. If you expand it, it can be written like this or this. The carbon in the COOH group is always carbon number 1 when you come to name it. Here's an example. 3-methyl-butanoic acid. So carbon number 1 is always the carbon within the carboxylic acid group. The next one would be 2, carbon number 2, and the next one is carbon number 3. That's why it's called, in this case, is your methyl group, and it's 3-methyl. Okay. Carboxylic acid group contains carbon number 1. Carboxylic acids are found in lots of fruit. If you go through the series, the simplest one is just a COOH group with an H connected to the C as well. That's methanoic acid. The next most complicated one is ethanoic acid, found in vinegar. And then there's propanoic acid, and so forth. Notice how the COOH group is always carbon number 1, it's always at the end of the molecule. Some organic acids have even more than one COOH group. For example, citric acid has 3. One on this side, one on this side, and one in the middle. Citric acid has also got an alcohol group on it. The physical properties are based on the fact that carboxylic acid molecules are polar. And the first 6 carboxylic acid, so from 1 to 6 carbons, are quite soluble in water. If you go any longer than that, they can be insoluble because of the long carbon chain. They have relatively high boiling points because they have a fairly strong intermolecular forces between the molecules. Really long ones are called fatty acids, and they're used in beauty products, would you believe? What are some of their chemical properties? Well, the obvious one perhaps is the fact that they're acids, so they're acidic. So if you use litmus paper, blue litmus paper, and you dip it in the acid, it will turn pink or red. Now, if it's pure acid, you have to use moist litmus paper. So it's always best to moisten your litmus paper first when you're doing organic chemistry. How come they're acids? Well, all acids release the hydrogen ion when they're in water. That's what makes an acid an acid. That's all acids, like hydrochloric, sulfuric, etc. The COOH group has a hydrogen on it, and that's the one that it donates to other molecules. So that is the source of the hydrogen ion, if you like. So if you put it in water, it's the hydrogen that's connected to the O that's lost. And that's why there's a negative charge there when it loses a positive ion. So the positive comes off, leaving a negative behind. Now, down here, you'll see a little bit more complicated equation. We'll talk about them later on. It explains why they're called weak acids, but that'll be covered in another topic. How do you make a carboxylic acid? Well, if you have a carboxylic acid if you have an alcohol like ethanol in, say, wine, and if you leave the top of the wine, it will turn sour. That's because the oxygen in the air is oxidizing the alcohol to form carboxylic acid. You can do it in the lab, of course, as well, using a strong oxidant like potassium dichromate or potassium permanganate. And in both these cases, you need to add an acid as well. For instance, sulfuric acid. That's why there's an H plus next to the reagent. Now it's just the ion, the dichromate ion, for instance, that's required. The potassium is just a spectator. And the same with this one, it's just a manganate ion that's required as the oxidant, although there's always a positive ion with it. And again, you need to acidify that as well to make it work. Amines. Amines always contain a nitrogen, and if it's a simple amine, it's a NH2 group. Position of the amino group is shown by the number within the name. For example, butane-2-amine means that the amine group, or the amino group, is on carbon number 2. Amines can be classified as primary, secondary, and tertiary. Most of the ones we'll be using will be primary. Now, primary means a little bit different than it does with alcohols and haloalkanes. In this case, primary means how many hydrogens are attached to the nitrogen and not the carbon. So if it has 2 hydrogens attached to the nitrogen, it's primary. Use that symbol to mean that. If it's got only 1 hydrogen attached, it's secondary. And if it's got no hydrogens attached, it'll be tertiary. So some simple examples: methanamine, ethanamine, propan-1-amine, propan-2-amine. Notice how you can put the NH2 on different carbons in propane, whereas you can't do that with the first 2 because they're too small. What are some of their physical properties? Well, like carboxylic acids, they're quite polar molecules, so they're very soluble in water, and they have comparatively high boiling points. They have a fishy sort of smell, a bit like ammonia. In fact, rotting fish give off amines. That's why they smell. The smallest amine, methanamine, is a gas at room temperature. What about some of their chemical properties? Well, the amino group, the NH2 group, makes amines basic. What does basic mean? Well, it means these molecules can accept a hydrogen ion. So the nitrogen has a lone pair of electrons on it. We'll talk about them later. And that's where the extra hydrogen attaches itself, because it's positive and it likes electrons. So instead of NH2, we get NH3+. And that has similar properties to the ion that's related to ammonia. And the ion related to ammonia is called the ammonium ion. Okay? And it has a positive charge as well. So these are methyl ammonium ions. That's what it's called, methyl ammonium. So it has the same ammonia name there. Now again, we'll deal with this part later. That explains why amines are weak bases. And with litmus, you use red litmus this time. And again, you need to moisten it if the amine is pure. How do you prepare an amine? Well, you need to start with a haloalkane. And to the haloalkane, you add concentrated ammonia. So there's 2 examples there. Bromoethane, reacting with concentrated ammonia, will form ethanamine. Chloromethane, reacting with concentrated ammonia, will make methanamine.